Hey, what's up, chat? Welcome to Unit 9, Day 1. In this lesson, we are determining whether or not events are independent or dependent, all right? And so, first, I'm going to go ahead and define them, all right? So, independent events are events that are not, okay, they are not affected by previous events, okay? And so in probability, what this means is the first event does not have any effect on the second one, okay? And so some examples that we can just kind of write here in this little space is when we have like a coin or a spinner, or if we have a dice, right? Or if we are, maybe we have a bag of some items and we are replacing it. All right, whenever we are doing these things, then the first outcome is not going to affect the second one, right? So if I flip a coin, right, what I flip the first time has no effect on what I flip the second time. Or when I have a spinner, if I spin a spinner, what it lands on the first time has no effect on what it's going to land on the second time, all right? And so these are some examples of independent events. The second is dependent, okay? And so a dependent is where one event, it does affect, right? So we're just going to say that it affects the probability of another event, okay? And so the key here is when you have a dependent, imagine you are taking something out and you're removing one of the options, and that is going to change the outcome of the second event, all right? And so what I want you to put here is I want you to put not replacing something, okay? And again, this could be not replacing marbles or chips in a bag or whatever, okay? So these are the two, okay? So I have given you the same problem, and I want you to read these two examples, and I want you to box or highlight what makes one problem different from the other, okay? So you're going to notice a lot of the details in the description of the problem are exactly the same, but there's one key word that's going to separate these two, and I want you to figure that out, all right? So I want you to pause the video. I want you to read the two scenarios, the two questions, and then I want you to highlight what makes one side different than the other, all right? So what's the difference? Spot the difference, if you will. All right, so the first one says, Jill picks a marble at random from a bag containing 5 green, 9 red, and 6 blue marbles, puts it back, and then picks another marble at random. What is the probability of selecting a red marble followed by a green marble, okay? And then on this side, and hopefully you saw, the difference is, in this one, we put it back, and in this one, it is without replacement. Okay, so that is the terms that makes these two different. Okay, so it is independent whenever you put it back, whenever you replace it. All right, and it is dependent whenever you take it and you remove it and you're losing one of the outcomes for the second. All right, so this next part kind of tells me how to find the probability of these two, okay? So if I'm finding the probability of a red, I want to see how many red I have, okay? So I have 9 red, so I have 9 over the total, okay? And my total is, is 20. I'm just adding. The 9 plus the 6 is 15, and the 15 plus the 5 is 20, all right? And so I'm finding the probability of the first event, and I'm going to find the probability of the second. So the probability of finding a green is 5 over 20. And again, my total did not change because when I took a red marble, I put it back, right? And then I just multiply these, right? And so you can use Desmos to just multiply, right? When I get this, I'm going to get 45 over 400, and that can be simplified You don't have to do this part. I'm just simplifying this. This is a kind of an easier way to do that. So this is going to simplify to 9 over 80. And making sure that, yeah. So that is my fraction. Maybe that can be simplified, but for the sake of time, I'm going to move on. All right. Now, this other side, if I'm finding the probability, I'm finding the probability of the first event, then the second event, then I'm multiplying it, and then I'll simplify. Okay, so the probability of getting a red is 9, right? So I got 9 over 20 total. And this time I take it out and I do not put it back. Again, without replacement is the key there. Okay, so I am not putting it back. So therefore, I'm going to lose one of the marbles because I just took out a red, and now I have 5 green out of 19. Okay, so 5 out of 19, and that is going to give me, you know, my answer here. So then I just multiply this across. Okay, 9 times 5 is going to give me 45. 20 times 19 is going to give me 380. Okay, and then I can simplify that. And I'm simplifying this. 4 times 9 is 36. 36. So it'll be 76. Okay. All right. And so that is my simplified answer. All right. So what you should notice is, again, the same scenario, if one is independent, it's going to have a different probability than if it's an independent event. All right. And we're going to talk about more about this later. But all we're doing today is I want us to, be able to determine whether or not it's independent or a dependent event. Okay. Before we do this, how does replacing and not replacement affect the probability of two events? Again, if you put this in your Desmos calculator, figure this out as a decimal, or maybe you could just tell this is less than 9 over 76, okay? So in other words, when you not replacing, non-replacement leads to a greater probability. And the reason that is because you have fewer options the second time around. Okay. So again, not replacement leads to a greater probability. So again, if you were to convert this, 9 over 80 is smaller than 9 over 76 because there's fewer there. All right. Now, so here's what I want you to do. For the next 4 problems, all you're going to do is you're going to read it, and then you're going to tell me, is it independent or is it dependent? Okay, so let's look at the first one. All right, Sophie has a box that contains 10 socks. She has 5 green, 3 black, 2 blue. Sophie reaches and grabs a green sock and then grabs a blue sock. Is this independent or is this dependent? Okay, the key is it does not say that she puts it back. So she grabs a green sock and then a blue sock. So this is dependent because Sophie doesn't replace it, because she does not put it back. So when she grabs a sock the first time, she's going to lose one. So then the second time, there's going to be fewer socks. So there's going to be a greater probability of getting, a blue sock the second time. Okay. So again, it changes. And so it does affect. The second event does change the first one. I'm sorry, the first one does change the second one. Okay. Look at question number 2. A deck of cards contains six equally shaped cards. William randomly selects one card from the deck and does not replace the card. Does not replace the card, then randomly selects the second card. What is it when you do not replace it? When you do not replace it. Okay. If you guess dependent, you are right. It is dependent because you did not put it back. Because the card is not being replaced. Right. Now, if you have not paused it at this point in the video, I need you to pause it, and I need you to do question number 3 and number 4 on your own. Okay, the shelf in the grocery store has 15 boxes of Cheerios and 5 boxes of Lucky Charms. What is the probability that the store clerk would choose a box of cherries, put it back on that should be Cheerios. Okay, that will be corrected on yours. Cheerios and put it back on the shelf, then picks a box of Lucky Charms. Again, the key here is that we put it back on the shelf. We put it back. When we put it back, that is independent, okay? Because the number of outcomes is not gonna change, right? We picked it up, we put it back, so now we still have the same total. Because the clerk the clerk put the box back. All right, and then lastly, a jar holds 15 red pens, 10 blue, and then 5 orange pencils. 1 pencil is chosen, it is put aside, and then a second one is chosen. What's the probability? Again, we're not finding the probability, we are just determining whether or not it's independent or dependent. And this one is dependent because it is put aside. Okay, it is not replaced. Because the pencil is put aside. Okay, so in summary, right? Independent events, okay, are ones that do not affect, right? It is not affect. Okay. And the way we don't affect is when you have, maybe you have a spinner or coin, again, doesn't change, but the key is you are replacing it. You are putting it back. And then dependent is when it does affect. The first outcome does affect because you take it, you remove it, and then you do not put it back. All right. So that is the key for identifying independent or dependent events. All right. And so you're going to do some practice with this. Let me know if you have any questions. Peace.